All right, it's 12 o'clock, and welcome to this week's Iowa Learning Farm Conservation Webinar. I'm Matt Helmers, and getting to host the webinar today, and excited to welcome two colleagues from the Agricultural and Biosystems Engineering Department. So we'll have with us today Philip Rockson, that's a PhD student in ABE, and Dr. Daniel Andersen, that's an associate professor and extension specialist, aka Dr. Manure, I think, if I'm not mistaken. So we got Philip and Dan here today to talk to us about roots, residue, and returns, how manure and cover crops work together. So really looking forward to this. And as always, if you have questions, please type those into the chat box and we'll get those to Dan and Philip at the end of the talk. With that, gentlemen, the virtual floor is all yours.
All right. Thank you, Dr. Helmers, for the introduction. As you mentioned, I'm Philip Rockson, a graduate student here at Iowa State University, and I'll be presenting with one of my co-advisors, Dr. Dan Andersen. So today we'll be speaking on cover crops, manure, how you could integrate them and how you could get value out of them whilst reducing the environmental leaching. I'd first like to acknowledge my other co-advisor, Dr. Raj Raman, who is unable to join for this presentation. We also had help from the Iowa State Northeast Research Farm and the Water Quality Research Lab, as well as my former colleague Gabi and some undergrads who helped us with this work. So nitrogen is one of the critical elements in plant production or for any biological systems. But however, when we leave this nitrogen on the field in form of fertilizer or manure being applied to our soils, it becomes a water quality issue. Hence, we need to find ways in which we could reduce the excess nitrogen from our soil. So here on our map, we could see the red spots on our map where, especially here in Iowa, it's above the EPA requirement, which is 10 milligram per liter, a lot of red dots being scattered all over the state of Iowa, which is not ideal for water quality. However, farmers also still need to sustain their yields or even increase their yields year after year. But they also think of ways to minimize this nutrient losses through subsurface drainage or even through irrigation. Sorry, through erosion. So in terms of applying nitrogen or providing nitrogen to crops, typically there are two main ways farmers go about it here in the Midwest. It's either through they use manure or they could apply UNI or inorganic fertilizer. So when we deal with manure, there are two risks or the duration or the timing of the manure application can pose certain risks or challenges to farmers. When a farmer decides to do a fall application, they have to deal with leaving it on the soil from, let's say, November right through May or April before the planting of the corn is done. And this is potentially could lead to some leaching in the soil or within the subsurface drainage. If a farmer also decides to use a spring application for manure, they may need to deal with compaction of the soil. It may delay the planting of the corn, and the nitrogen might also get tied up in the soil before it's released to the corn for production. So these are balancing acts farmers deal with on a daily basis, although most farmers tend to rely on the fall application, which gives them enough time, and they are not cranked up during their spring application. So one of the ways farmers try to address uh, excess nitrogen leaving the soils is the use of cover crops. And cover crops potentially is able to take out the excess nitrogen from the soil. With farmers who have really bad or in bad spots, the cover crops is able to reduce that erosion. Over time, it helps to also build the soil structure, increasing microbial activity within the soil. And in certain cases, they are able to reduce the weeds. This indirectly also means you may apply less herbicides on your plots. With every management practices, there are some challenges as well. You may have to purchase these cover crops, which increase your cost of production year on year. And if not managed properly, there could be some yield drags at the end of the day. So when deciding on which cover crop species to use, uh, most farmers tend to look at the reason why they need. If someone has really bad erosion, they may go for one that has large root systems and biomass to reduce that. And if someone is also interested in grazing, they also go for pick a specific species. However, most farmers tend to use, or most farmlands tend to use annual cover crops. We've been researching some other species of cover crops, which are called the perennial ground cover, or in other words, known as living mulch, as an alternative to these annual cover crops. The benefit of this is you plant once and may not need to replant year on year, as done in the annual cover crops. And also, we are picking species that tend to go dormant naturally during the summer. This helps to manage the competition between the cash crop, which could be the corn and soybean, and the cover crop. So as mentioned, we're trying to answer the question how we could use both manure, which could be a cheaper alternative of source of nitrogen for farmers, with cover cropping systems. So when you begin to introduce two management practices, having the cover crops and also manure application, you introduce additional complexity to your system. Unlike just going ahead to grow your corn without any form of uh, cover crops on your farm, it needs to be managed properly so that the corn or the soybean gets the most benefits out of the system you use. So the corn is able to absorb most of the nitrogen, it's able to access the water being supplied either by irrigation or through precipitation. The other thing we may need to think about is the greenhouse gas emission from the manure if not applied properly. So we decided to try to set up a field plot so we could test our hypothesis. We decided to try different manure application timing, multiple cover crop species, and also compare them to the conventional way corn and soybean are produced. So an overview of the experimental setup we did, we had this set up in the Northeast Research Farm. It's a 36-acre plot, each individually tiled, and we're able to sample from the middle tile. So each plot has 3 tiles, 2 at each of the edges and 1 in the middle. And the sampling is done only from the middle tile in order to prevent influence from other plots. So I'll move to the systems to compare. So for our continuous corn systems, we had 4 treatments. We compared the control, where we did the 4 manure application. It has no cover crop. And since it's a continuous corn, we have corn each year. The nitrogen application rate was 200 pounds per acre, and each of the 4 application was strip-tilled. The second treatment, we have the same here, manure application in the fall. And by in this case, we had CRI being planted right after harvest. And this is an annual cover crop with the same application rate of 200 pounds per acre. The third treatment, instead of having the rye planted after harvesting, we did an early seeding of the rye right in the middle of September while the corn was still on the farm. And our final treatment was our PGC grass or our perennial grass, the Kentucky bluegrass, growing on our field. So this slide shows an image or shows pictures of some of the treatments we had on our field. So I'll move right to the results we had from our tower drainage in terms of the nitrogen leaching out. For our continuous corn production, we see that the Kentucky bluegrass, which is our perennial cover crop, had the least seasonal nitrates coming out of the soil for both spring and during the summer. it was able to scavenge the excess nitrogen from the plot without going through the soil profile into the drains. This was quite impressive because we had very little coverage, about 80% on the plot. The image shows the grass strips lying here. You could barely see the grass growing, but we had substantial reductions from the perennial ground cover. We also see that the early seeded rye also was the second lowest compared to the control and the cereal rye drilled during the harvesting season. When we flow with these results, we consider the Kentucky bluegrass still is the lowest, sorry, still has the lowest nitrogen release from the plots, followed by the early seeded rye and the cereal rye seeded after harvesting. However, we see that the control is way lower than the cereal rye being used. And we think it might be due to some mineralization happening on the plots with the cereal rye drilled after harvesting. Comparing the flow of nitrates into the drainage to the yields, the yields were quite comparable for all treatments. We had over 155 bushels in each of the treatments, where the plots with cereal are having the highest yields at the end of the day compared to the control. The control treatment and the KBJ were identical. Hence, we did not see any impairments by the cover crops on the corn yield. I'll move to our corn rotation plots, and here we did apply manure during the spring for all treatments for our corn rotation. So our first treatment is the control. There's no cover crop. These plots are no-tilled, and the application rate for each of these plots was 150 pounds of nitrogen per acre. The second treatment, we have a cover crop species being planted right after harvesting, and we also had a split manure application. So we applied 100 pounds of manure during the fall, and we side dress UNI of 50 pounds during the spring. And our final treatment for the corn rotation, we have a second species of RHB, which is also a perennial cover crop, with the same application rate. So comparing the nitrates coming out of the soil for the respective seasons, during the spring, we had substantial reduction from the cereal rye and also the RHP. But however, when we moved to the summer, it was higher than the spring nitrates coming out, which is quite unexpected. For the experiments we've conducted so far, we see that during the summer, the nitrates are way lower than the spring. But in this case, we saw a higher nitrates coming out of the soils during this summer. The PGC grass, in this case, was the RHB, had the least nitrates coming out of the soil and provided substantial reduction in nitrates at the end of the day. Then our split nitrogen application, which was we did 100 pounds per acre during the fall and 50 in the spring, had the highest amount of nitrates coming out of the soil compared to the other treatments. For the flow-weighted average of the nitrates leaching out of our soils, we see that the RHB had the lowest nitrates at the end of the day. It was able to reduce the nitrates by more than 20% compared to the other treatments. Here as well, we see that the split nitrates has the highest amount of nitrates coming out of our soils. And our second cover crop, which is the cereal rye or the annual cereal rye, had also the second least nitrates coming out of the soil. So we see a clear impact of our cover crop species on their respective treatments and plots. When we look at the yields of those treatments, unfortunately, the RHB had the least yield. We lost about 60 bushels per acre in the RHB treatment. However, the Yield in the CRI was comparable to that of our control, and they were both about over 188 bushels per acre. When we compare these two to our split nitrogen application treatment, it was a bit lower, although it was not statistically different from the others. So the RHB had a least yield, and that was statistically different from or significant from the other treatment. And it was mainly due to two reasons. We had poor management. You can see in this image how the system was set up. We have almost 100% coverage, the grass covering the entire plot with no zones left for the crop to grow or for the corn as a cash crop to grow. I'll transition to our last treatment. So this is the soya bean rotation comparable to the corn rotation we did. And it's almost identical. However, because this is soya bean, we did not have any manure being applied. The manure values you see here are from the corn of the previous season. So as we had in the corn, we have a control where there's no cover crop. We have the annual cover crop, which is cereal ripe, planted right after harvesting. For our split money application as well, there's no cover crop. And for our RHB or the Redox hybrid babosa, the perennial cover crop, it was also left from the previous season. When we look at the seasonal leaching from the soybean plots, our cereal rye had a lease in both spring and summer. It was way below the 10 milligram per liter, which was good news for us. The RHB or the Redex hybrid proposal had a second least nitrates coming out of it. So although it was a little bit higher than the 10 milligram per acre. When we flow with these values, we still see that the CRI plots did have substantial reductions in nitrates coming out of the soil. This was primarily due to the previous season's treatment where we had some cover crop growing on those plots prior to the experimental design or being set up. So it points out the fact that when you do have cover crop or you do have some form of cover on our soils without leaving them bare, we're able to reduce the nitrates coming out of the soils substantially. For the yields in this plot, we see that in all the treatments for soybean, the yields were comparable. It ranged from 63 to 66 bushels per acre. And we did not see any impact of the cover crop, as we saw in the case of corn, reducing yields. So soybean was ideal in our study for using cover crops and without seeing any reduction of yields. So to conclude, there's a few takeaways we want to share with you. So when we altered the fall application of manure to spring, the yields were still comparable, and we could even, or we even saw that the yields from the spring manure applications were way higher than the fall manure application. This helps you to reduce the application rate of 200 to 150 without sacrificing yields. And that excess 50 nitrogen pounds per acre could be prevented from coming out of the soils and draining into our water bodies. The other takeaway we had was that we saw substantial reduction in nitrates or nitrogen coming out of our soils by using cover crops, except in I think one of the cases where but for most of our treatments, the cover crops was able to provide the scavenging ability to absorb the excess nitrogen from these plots. However, the corn seemed to be more sensitive to these cover crops if management is not properly done. Then the final takeaway was when we look at the split manure application, there was a greater risk of end loss from the from those treatments. So 100 pounds of nitrogen was done during the fall, and we had 50 during the spring. But this did not result in substantial increase in yields compared to just doing the spring manure application. But the nitrates coming out of these plots were higher than the spring applied manure. And since this was our first year of the study, so we did manage to learn some things from our RHB or our initial RHB treatments. We think you shouldn't go about the RHB as we did. So the first thing is you may need to have some crop zone in order to manage the competition between the grass and the cover crop. Since it was the first year as well, the grass was trying to establish and did not go dormant early. We also did some late suppression of the grass, and at the end of the day, it compounded and resulted to the yield loss we saw earlier. However, the RHB was able to effectively reduce nitrates in our soil, both seasonally and at the end of the season using the flow weighted average. So in our second year of the trial, we've improved their design. Their yields are already showing that they are almost comparable. We are yet to analyze that at the end of the day. So one of the takeaways we also always observe is that when you use a cover cropping systems in soybean, it's able to work well with the soybean. So we would advise that if you decide to try using any of the perennial cover crop species, ideally you should start in a corn soybean rotation with the establishment year going into soybean. Because the soybean tends to be more forgiving and we don't see any yield reductions. There are instances where we've seen even higher yields with soybean when it had some cover crop. So as we conclude, we'll be interested to know if you have any of these practices on your field, if you're using manual, the timing of your manure, whether you do the fall application, whether you have a split application or a spring application, if you're using any of the cover crop species we mentioned, or trying perennial cover crops or just sticking to annual cover crops. All right. Thank you.
All right. Thanks, Philip. And let's go to the next. I'll get through the logistical sides and then you and Dan can answer some questions because we've definitely had some come in. And please, others, get yours in. So if you watch this webinar live and are wanting to earn a CCA CEU, please email Elena Whitaker, ALENAW, at iastate.edu by 5 o'clock today and include your name, the name you entered to watch the webinar, and your CCA number. Again, ALENAW at iastate.edu. Let's go to the next slide, which if you watch this webinar live and are willing to fill out a voluntary survey, we'd greatly appreciate it. Only one survey response is needed for all 2025 webinars. So if you've done that, thank you very much. If you're willing, we'd greatly appreciate it as well. And you can scan that QR code. Okay, next slide should be a plug for the next webinar. If you can go to the next slide, Philip.
This was the last, sorry.
That's the last one? Okay, I will find it. So
Okay.
rest assured, we will have a webinar next week. And rest assured, the webinars are archived on the Iowa Learning Farms website and on the YouTube page. So we got some questions here. Maybe one of the first ones, what exactly is RHB? So I think you mentioned it quick, a radix bulbosa, but maybe describe a little bit about, is that a grass and what other plant species that we might be broadly familiar with would it be related to?
All right, and I'm going to help Philip out with the
Okay.
questions so he can take a little break after giving a
Okay.
great presentation and letting me rest. So RHB stands for Radix Hybrid Bulbosa. and it's actually a Mediterranean grass. So it's used to having a dry season and then a wet season, right? And that actually works a little bit to our advantage because it thinks when it's a wet season, turn green, grow. When it turns to a dry season, just go dormant, right? And that's sort of why we like it. And the Radix Hybrid Babosa is just because the company is Radix who sells this version, and they've bred it to be an improved version of seeds they found naturally. And the way I think about it, it's definitely a grass. And if you ever visit the South and go see their golf courses, since Matt's an avid golfer, it's a grass that people in the South, especially in Texas, like to use as a golf course grass to have green grass during the winter. Okay, so we've brought it north. And if you are unfamiliar with it, think about it just like a Kentucky bluegrass, but the worst Kentucky bluegrass lawn you've ever seen in your life. It's going to turn brown really early, and it's going to be a little bit on the sparse side. All right, and then we have a question about it being an invasive species, and I knew as soon as I started describing it that might come up, so I'm going to handle that one right away. It is technically listed as on the invasive species list. With that said, it's about the worst invasive species I've ever seen in my life. It doesn't spread very vigorously. We almost worry about it not being able to spread enough. So when you think about making this system work really well, I want to try and plant the corn in basically the same row every year, because if I move too much around, I'm going to be destroying that bulbous bluegrass. And it's not very vigorous in terms of reproducing or, yeah, sort of filling back in the gaps. It will, but it doesn't want you disturbing it. So if you're thinking I'm at a 30-inch and I'm going to move over 15 every year, that's probably not the system that we want in our perennial ground cover. So while it is listed as an invasive species, we have yet to see it leave any of our research plots. My understanding is that most of the seed heads it makes aren't viable. It mostly reproduces with making bobules, and they tend to fall right next to the plant and not get very far.
Okay. Thanks, Dan. So can you indicate what type of manure was applied and then maybe when it was applied? Yeah. And if you knew anything about the soil temp when it was applied?
Yeah. Okay. So this is a deep pit swine manure from a swine finishing farm located just down the road. It is a really nice manure. It's typically testing about 8% solids, and we are running between 65 and 75 pounds of nitrogen per 1,000 gallons. So that's, to me, a pretty average manure, but it is a sign of pretty good water management on the farm. But that's pretty close to the state average swine finishing manure these days. While we've done a whole bunch of studies on timing of manure application, this one specifically, we were trying to use best practices, and we've been applying roughly November 10th to November 14th in the fall. And we're always waiting until the soil is 50 degrees and cooling. We just took our pre-sample this week on Saturday from that pit to help us set rate for this coming year. And soil temperatures are still 55, so we're delaying on when we're getting on. So it has been a waiting game. We are using best practices, and normally we've been hitting a soil temperature between 50 and 45 degrees Fahrenheit at the time of application. Looking at the forecast to tell it's trending cooler. Some years that's easier than others.
Great. Okay. Can you define what you meant by early seeded cereal rye?
Yeah, so early seeded compared to our other one. In this case, to me, the early seeded cereal rye, both years that we've done this, we've put it on August 29th. So originally we were targeting Labor Day, but Matt and I are having a competition to see who can grow the best cover crop. We plant it with the red solo cup.
Dan consistently gets rain right after he plants his. Me, I get forecast of rain and then no rain when I plant mine. So, you know, yeah. Dan's better at conducting research on cover crops.
So we've been on August 29th trying to catch a rain, dropping everything we wanted to do that day to go plant to catch the rain that's expected. Did it again this year to catch that rain. And we're just really trying to replicate if you were using something with drops to put it on or flying a cover crop on. So we're roughly in that time window, and I've crept a little early, mostly because it's been so dry at Nashua in the fall that anytime there's rain in the forecast that looks like it's going to happen, I've made sure I get out and do it.
How much biomass have you seen for your rye and your various PGCs?
That is a great question. And Okay, historically at this site, we've been close to 1 to 1.5 tons of cereal rye. And if you want to be very disappointed with life, we had extremely low biomass this year beforehand. We had somewhere in the neighborhood of 1/10 of a ton of cereal rye and half of that, so 5/100ths of a ton of our perennial ground covers, which is basically nothing. It was about the worst cover crop I've ever seen this year. Last year, so the year that Philip showed here, we were close to a half of ton of cereal rye. So both years have been relatively dry in the fall, not helping us get a lot of growth. And then they've been kind of chilly in the spring, right? We went from cold spring to time to plant now. So we haven't got the most cover crop growth compared to maybe what we'd got in some of the past years with that. A couple things with that cereal rye that we're seeding early, you got to make a choice of where you plant that. I have been planting it, we have been planting it directly between the corn rows. And then since we're doing spring manure, I'm putting my spring manure right where that cover crop strip had been. So I'm getting decent fall growth, but by the time we pull our biomass sample, I've injected manure into it and sort of disturbed or wrecked some of my stand. So you don't see a whole lot there. With that said, it's been the same as what I've drilled, but I'd much rather go cover that drilled biomass because it's in a row and not all wrecked. But we've had very low cover crop stands the last couple of years, very low biomass for the perennial ground covers, but that's sort of what we'd expect with the perennial ground covers. I think maybe a goal with them to shoot for is somewhere between 1.25 ton an acre, probably more towards that 1/4 ton an acre for Kentucky bluegrass and RHB. So low biomass yields, but not out of the realm of what we would expect. But Kentucky bluegrass the last 2 years, really low biomass growth.
Okay. Guess there was, if the rye is not planted until late October, is there any benefit?
Yeah, so Matt was involved in some studies
Yeah.
where we did
Yeah.
this. We were trying to play around with when we plant cover crop, when we put manure on, and we have historically seen a water quality benefit from rye, even when we're planting on in October. And even in many of those years, we got to that 1 ton, 1.5 ton of cereal rye biomass in the spring. Even with this one, you have to squint a little bit, but I think you still see that water quality benefit with rye. Maybe not to the level we did when Matt was doing it and we were fall applying manure. So I think some of that is spring applying manure. There's not as much nitrogen to maybe protect, but we still are seeing that benefit. So even if it's out there late, you don't get to see the above ground biomass growth as much and celebrate as much, but we've seen some water quality benefits.
Did you notice any difference in weeds with the different cover crops?
No, not really.
Okay.
We don't get enough biomass, I think, to do anything for weed
Yeah.
control. And if I'm going to be slightly negative, with some of those perennial ground cover systems, we are more cautious about the things we spray, and we probably have a little bit worse weed pressure. You have to get your timing right for suppression and weed control. So that's been something that we're still trying to work out, and others on the overall perennial ground cover team are really focused on when do we spray, what do we spray to have effective weed control in those systems. But that's probably one of the points where that system's still lacking a little bit. In our cereal rye system, we're still pre-post. We're killing our cover crop with glyphosate about 10 to 14 days before we plant corn. And that would be our pre herbicide treatment, and then we're spraying a post. So we're not counting on the cover crop to give us any weed control, which means I'm probably not a great evaluation to say that it's not, but we don't trust it enough to sort of use cover crop in that way at these sites.
How often would you say the radix hybrid bulbosa might need to be reestablished?
Okay, a couple things on that. One, we don't exactly know. We're still early. Two, Philip told you that my first year was really bad. In my defense, that plant should go dormant roughly the beginning to the middle of May in Iowa. But turns out you have to establish it the fall before to get it to go dormant then. If you establish it in the spring, like I did, because there was basically no rain the year we wanted to establish it, it won't go dormant until mid to late June. And if you're wondering why we managed so poorly, I made a strategic decision that if it goes dormant in May, I'm going to live with this, take a little corn yield hit, and at least I'll have research plots with a great establishment. If it was going to go dormant in mid-June, I would have made a different management decision at the time. We would have strip tilled to have that crop grow some. So with the 2 years that we've had it there, it's persisted well for us. But you should be concerned about a couple things. One, if you are yielding 300 bushel corn, watch out for smothering. A lot of biomass on top of that radix hybrid babosa in the fall offers a challenge to it. So if you think about cereal rye, you have a relatively big seed, it will push through that. Uh, with radix hybrid babosa, think about it a little bit more like an iris in your garden. And if you have irises in your garden, you hear things like, don't throw mulch on top of them. You rot out the rhizome. Radix hybrid babosa can have a little bit more of that problem, especially if we have a wet fall with lots of residue on top of it. So I've had dry falls. I haven't had that challenge, but it is something that we want to watch out for. I think a realistic goal, we're trying to make it last 5, 6 years right now. And if we could find some corn stover markets, if you have beef cattle are taking off corn stover for silage, I think you might be able to find ways to stretch it to 8 years. But it's very much in the learning stage on that. So right now we're shooting for 4 to 5. I'm confident I'm making 4 to 5, and then the seeding cost will be cheaper than cereal rye because I've written it off over enough years. Anything less than that, it probably gets more expensive for cereal rye. So that's sort of why we want to make it that long. And I feel like at Nashua, we're going to make it that long. So I feel like I'm doing all right.
And now I get the prerogative of asking a question that from me. Could you graze this? Is there enough growth to potentially graze this in the late fall or early spring?
You are not grazing our perennial ground covers for the perennial ground cover. Now, if you had some shatter loss in your corn head and you had the right weather conditions to go out there and graze it, go right ahead. They'll probably eat some of my grass, and I won't complain much about that. But if you have bad conditions, radix hybrid babosa doesn't spread fast. You can't hoof it up and kill it. So there will be some concerns on that. If you are in a grazing program, you're going to probably put on cereal rye, seed at a little higher rates, and take advantage of the more biomass it could or should produce. So when we think about that perennial ground cover, it was really more of a system that we thought might be with people who don't have cattle or need that forage.
Okay, great. Was there any tillage on the corn and soybeans? I think you talked how they were planted. And then how far north would you say the radix hybrid babosa might grow?
Well, that's a great question. At least through Wisconsin, I would say. So if you start getting into Canada, I'd have to look a little bit more at your weather conditions and your growing season. But I think if you can establish a cereal rye cover crop, you can probably make the radix hybrid babosa grow for you. The one challenge you're going to have would be in the spring. I really wanted to try and get it to make bobules, or at least close to making seed, which should be in that May timeframe in Iowa. And if you push your cropping season too much ahead of that in Canada, or if it comes back a little too much later, you might not be able to make it persist as long. So that would be the concern. We have a collaborator, Dr. Fay here at Iowa State, trying to understand how some of these grasses perform in Iowa long term, and hopefully that'll provide insight as we go north. But that's sort of where we are on that.
All right. This might be Philip. Can you indicate how you collected the water samples to measure nitrate loss?
Okay, so we have automatic samplers. It's collected weekly. It's about 0.2% of the total flow, and we get assistance from the water lab here to make the nitrate and phosphorus measurements.
So the center tile line in each plot drains to a sump. That water is then pumped from that sump through a flow meter to get an accurate flow measurement, and it takes a 2% of the water and puts it in a sample collection jug that the farm collects for us weekly that gets analyzed. So measuring the center tile line only of the plot and getting a flow weighted sample of what's going there, but really using the idea that pumping it's the easiest way to get a sample from what's going on that's flow proportional.
Great. Here's kind of an interesting question about thinking about manure availability. I think with swine manure, we think it's close to 90 to 100%. So maybe we don't think as much about second year availability, but would you expect second year manure and availability to change with fall versus spring application?
Okay, that is a great question, and I'm going to answer both the easy version and the,
Okay.
the the little bit better version. So swine manure is 90 to 100% available the first year. All our research continues to suggest that it's much closer to that 100%. When I go pull manure out of a deep pit barn, it's averaging about 80% ammoniacal nitrogen. So that's in a form that's instantly plant available the moment I put it on. I do not expect anything you do to change the availability of swine manure in first to second year. It's all there that first year. When we think about some of the other manure types that have a higher C to N ratio and start with much more of their nitrogen in the organic form rather than the ammonium form. So I tend to think in my head, bed pack manures for either dairy or beef, or those poultry manures where I'm using a bedding, so broilers or turkey. In theory, you could a little bit, but the weather variability from year to year is higher in terms of the microbial potential that you're going to have than what you're causing between fall and spring application. So that's a fancy way to say, yeah, it does, but not within the uncertainty of what we're able to tell you. So yes, not for liquid manures generally, and for solid manures, it's a big enough range that we're sort of recommending that you won't be able to pick it up. The one thing to be maybe cognizant of, especially with those poultry litters or layer manure, when you start putting it on in the fall, you have more time for mineralization. And some of those manures, especially laying manure, probably are more prone to timing than that bed pack manure in terms of loss that you might still get in the fall. Michelle Sapir and I have some poultry litter plots in Ames that we've sort of replicated some of the timing work we've done. And in those wet springs, we see sort of the same thing we saw with swine manure. Timing might matter. In dry years, it doesn't seem to matter as much.
Okay. I think you managed to minimize any of this, but any allelopathic effects with corn following the raw rye or seedling delay or seeding delay, I guess, seeding delay.
And we have not seen that. We are working hard to terminate our cereal rye 10 to 14 days before corn planting and roughly a day or two before soybean planting to a day or 3 days after soybean planting. And with that, we haven't seen any issues with allelopathy. We've seen basically the same emergence, whether it was the control or the cereal rye cover crop fields. And at least recently, we've seen the same yields in the cover crop and control fields. I will admit, in dry years where we may be running short of water, we did see some yield drags with our cover crop if we didn't get it terminated early enough in the spring. And way back a decade ago, when Matt and I first started doing some of this with early fall applied manure, the cover crop performed really well from an environmental standpoint, but we saw some corn yield drag, which we got better
Yeah,
at
it was mainly in year
the
one.
year one. Yeah.
Yeah,
So I think
yeah,
that year one, it had a growing season where it maybe stole a lot of nitrogen. After that, it gave it back, I think.
yeah.
And that's why we got back to maybe the same yield as manure at roughly the same time. But that first year was a little rough. But after that, we've been good. And that's with no supplemental nitrogen in the cover crop plots or starter nitrogen. It's all been reliant on that swine manure application.
Here's one kind of more on the nitrate concentration, but what was the nitrate concentration between fall and spring application?
Do you think that question's about the manure or the water?
I think the
Manure.
water.
Okay, the water.
Yeah,
Uh, a couple things on that. I'm gonna try and use Philip had a slide where he showed you spring manure corn and then our split manure with corn. And that's in a corn and soybean rotation. So split manure was 100 pounds in the fall, 50 in the spring, not all in the fall. And we went from a flow weighted average of about 32 in our just corn with spring applied manure up to 36. So it wasn't it was a statistically significant difference, but barely in that case.
okay.
But we do see a shift, and that continues the trend that we've seen at this site of timing looks like it matters at that site in those soils for our conditions of when we were putting it on. But I would say that trend, it's less here when I split to move some in the spring than all fall compared to what we saw just with fall and spring. And it's nowhere near to the level that we saw with early fall manure, which to me was roughly the beginning of October, compared to a spring, in that case, UAN application. So moving some of it to the spring helped, but it's not as good as putting it all in the spring. Noting that this year that Philip showed was a really wet spring. So a year that probably, if there's a seasonal effect, exacerbates that effect. During dry years, we saw no timing difference at this site. So weather plays a role in that.
Yeah. Okay. I think that answers most of the question. There was one on research the best effective rate of manure, kind of nutrients per acre side of things.
Yeah.
Anything on
So
that?
we rarely run manure studies to do exactly what you said. Instead, the approach has been manure nitrogen is the same as commercial nitrogen. So use synthetic fertilizer studies to determine the opposite rate, and then try and run some strategic studies to understand maybe what characteristics are different between commercial fertilizer and livestock manures. For example, we talked about availability earlier. Just because I have 65 pounds of nitrogen per 1,000 gallons in swine manure doesn't mean it's all available. Now, our research has suggested it is for swine manure, but if you'd go to something like bed pack cattle manure, tested and it's at 20, 25 pounds of nitrogen per ton, you probably aren't getting all that in your growing season. So we'd make an adjustment to that. So we'd run a study for the availability to adjust it. But really, available nitrogen, whether it's from manure or commercial fertilizer, the right rate should be basically the same, with maybe some small effects for biology and maybe some nitrogen tie-up if I'm using a bed pack manure, but really using adjustment factors to get to that rate number.
Okay. All right. Thank you so much, Philip and Dan. And Philip showed that Catherine Crawl O'Brien will be talking about butterflies next week. So we're gonna switch from manure to butterflies. So please tune in next week. Catherine Crawl O'Brien, same time, same place. And again, if you need a CCA CEU, please email Elena Whitaker, ALENAW at iastate.edu. I thank you all for attending. I thank you all for the great work you do all across the country and into Canada. We have a Canadian representative, which is always great. Great to have Jack on, and I know there are others at times too. So everybody have a great rest of your day and week, and thank you so much, Dan and Philip.
Thanks, Matt. And my daughter will be excited to hear about butterflies next
Yeah,
week. I'll have to show her that
yeah,
one.
she should tune into that one. Exactly, exactly.